Okay, grade 12s, let's revise what we call the exponential equation. Okay, this is important, the exponential equation. You're going to need this in sequences and series a lot. Okay, so the exponential equation, how does this work? It says basically, if you've got an equation 3 to the exponent x is 9, the exponent is the unknown, and you've got to solve for x. Now, how we did this in grade 10 is basically you make the bases the same. So you would say 3 to the x is equal to 3 squared. And if the bases are the same, we can equate the exponents, so therefore x is equal to 2, which makes sense. 3 squared, or if x is 2, 3 to the exponent 2 is 3 squared, which is 9. Okay, now there's another thing that came up in grade 11 about these things. It's very, very important. Whenever you solve an equation, like that a to the x is equal to a number, that base has got to be a positive number. Okay, and the base can also not equal 1. This is all from grade 11 days. Okay, now we know that it's so important. In other words, what we're saying is that a to the x, the expression a to the x, must always be positive, bigger than naught. Okay, now we'll explore or revise some examples of this as we go along. Now, just to prove that this is positive, take the expression 3 to the x. Okay, let's look at that. I want you to pick some x values. Suppose you had x is equal to negative 2. What do you have? 3 to the negative 2 is 1 over 3 squared, which is 1 over 9, which is positive. If x is equal to negative 1, that would be 3 to the negative 1 is 1 over 3, which is positive. Okay, if you have x equals 0, 3 to 0 is 1, which is positive. And if x is equal to 1, 3 to the 1 is equal to 3, which is positive. Now notice that you've got 0, some negatives, and some positive numbers, and the expression 3 to the exponent x will always work out to be a positive answer. So that's why we can say that a to the x is always positive. It can never be negative. Okay, so that's an important revision from grade 11 days. Now, in other words, if you had an equation like 3 to the x is equal to negative 3, there would be no solution, because why is that this expression is always positive, so there is no value of x for which 3 to the x would be negative 3. So bear that in mind. If there's a negative there, there's no solution. Okay, so if we explore some examples of this, let's have a look here. If I said to you, solve for x here, 6 to the exponent x is 36, well, we can make the bases the same. So we can say 6 to the x is equal to 6 squared. We're writing the base as 6 there on the right. The bases are the same, so we can equate the exponents. 6 squared is 36, so it works. Okay, and then number B, let's have a look at this. If they said to you 6 to the x is equal to 6, well, what we need to do is we can put an imaginary 1 there. 6 to the 1 is 6, and so x is equal to 1 if you equate the exponents. And it's true, because 6 to the exponent 1 is in fact 6. Don't treat that as a naught there. Okay, there is a difference. If you've got, for example, 6 to the x is equal to 1, then what you can do there, you know already that x is naught, because 6 to the naught is 1. But you could go like this: 6 to the x is equal to 6 to the naught. Now equate the bases, and x is naught. Okay, so that's quite important. Now let's get a little bit more technical, as we did in grade 10 and 11 with these things. What if you had to solve for x with this equation? 25 to the exponent x is equal to 125. Now the trick is to get the bases the same. 25 is 5 squared, okay, to the x, and 125 is 5 cubed. Now if you multiply those using the laws of exponents, you get 5 to the 2x is equal to 5 to the exponent 3. Okay, so the bases are the same, so you can equate the exponents. Drop the bases, in other words. Divide both sides by 2, and there we've got it. We've got x is 1.5. Okay, alright, let's revise a few more quickly. Number E, how about this one? If you had negative 16 to the exponent x equals negative 32. Now here, there are two negatives on both sides, so you can, of course, immediately drop those negatives. So you could say 16 to the x is equal to 32. Alright, now obviously we need to change these bases to something worthwhile. So what I'm going to do is I'm going to change 16 to 2 to the exponent 4. 2 to the 4 is 16 and 32 is 2 to the 5. Multiply those two. 2 to the 4x is equal to 2 to the 5. Okay, equate the exponents because the bases are the same. So x is equal to 5 over 4. Okay, now be very careful with this. What if you have something like this, number f? If you had an equation like this, say it was like this, say you had 6 to the x is equal to negative 6. Well, immediately, there's not a negative on the left that you can divide both sides by negative. So an answer like this would be no solution to that equation. Okay. And then if we look at number G, have a look at G. Watch out for this one. 5 to the x is equal to 1 over 25. Now, all of this is in the grade 10 and 11 Moby School lessons in more detail if you need help there. But we're just revising these things for sequence in the series that's coming up in the lessons to follow. Now, what we can do with this guy, we've got 5 to the x is equal to 1 divided by 5 squared for the 25. Now, remember this rule. A to the minus n is equal to 1 over a to the n. If you remember that from grade 9 days. Now, if I reverse it, I can change 1 over 5 squared to equal 5 to the negative 2. It's the reverse. 5 to the negative 2 is 1 over 5 squared. But I'm reversing that little rule there of exponents. Okay. Then the bases are the same, so you can equate the exponents there. Okay, and then another important one that can come up as well, number H. What if you've got 2 to the x is equal to a decimal, 0.25. The way around the decimal is simply this. You go 2 to the x is, okay, 0.25 is 25 divided by 100, as you did in primary school. Then you can say, well, let's tidy that fraction up. That's the same as 1 over 4. 25 goes into 100 4 times at the bottom there, and then you can say, well, 2 to the x is 1 over 2 squared, and then reverse the exponent rule, 2 to the negative 2, bring it up there, and the bases are now the same, so then x is equal to negative 2 if you equate the exponents. All good stuff from earlier years, just revising these important things.